What on earth is an algorithm? This, of course, is a very legitimate question because everybody these days is talking about algorithms. And quite frankly, algorithms are everywhere. They are in our computers, in GPS machines, in Google search engines, in our calculators, etc., etc. But of course, the problem is that when you are a layman and you listen to professionals talk about algorithms, you can be excused for thinking that an algorithm is this mysterious thing out there that somehow magically produces results that you are seeking. This is quite far from the truth. So before we get started, let's get this mystery out of the way. An algorithm is a set of rules or instructions or steps that we can follow to get to a certain result. For example, I can give you a set of instructions on how to bake a cake. You follow the instructions, you end up with a nice cake. I hope so. Another example is that I can give you a set of instructions on how to calculate your pension. You follow those instructions, you get the amount that you get for your pension. Now, in this video, I would like to illustrate this by solving a system of 3 linear equations in 3 unknowns. They read as follows. These are the ones you can see here. X plus 2y plus 3z is equal to 11. 4x plus 7y plus 2z is equal to 23. 2x plus y plus 5z is equal to 17. Now, before we get started, we need to put together what is called an augmented matrix. So let's write it down here. Augmented matrix. How do you spell that? It's A-U-G-U-M-E-N-T-D matrix. What kind of a matrix is that? Well, that's the matrix I've written here. It's put together by taking the coefficients of our variables x, y, z. We put, of course, the in column 1, the coefficients of x. So x here, as you can see, it's 1, 4, 2. There is your 1, 4, 2. Your y is 2, 7, 1. There is your 2, 7, 1. Your z is 3, 2, 5. There is your 3, 2, 5. This little matrix here that we've got consisting of the coefficients of x, y, z is called a coefficient matrix. So let's write it here. So that's our coefficient matrix because it consists of its elements. Its elements consist of the coefficients of our variables x, y, z. Now we juxtapose next to our coefficient matrix the constants which are on the the right hand side of our equations, which are 11, 23, 17. There is your 11, 23, 17. So all this together is what is called an augmented matrix. Now let's rewrite our augmented matrix here before we start with our algorithms. So it's 1, 2, 3, 11, 4, 7, 2, and 23, 2, 1, 5, and 17. Notice I have not written the red line here because it will get in the way of our calculation. Now, what we want to do here, our first assignment is to make sure everything below this first element here, let me circle it in red, this first element here, everything below it is equal to 0. Now, the kinds of things that we want to perform here are what are called elementary row operations. So it's elementary row operations. I'll just write operations ops for short. I hope you understand that. So we want to perform elementary row operations. What are these? These are calculations. This is like when we multiply a row by a constant, we add one row to another, etc., etc. But we do that according to a set of rules. Rule number 1. we are allowed to multiply a row by any constant. For example, I can take row number 2, multiply it by 10, or take row number 3, multiply it by 17. It's allowed, as long as we multiply all the elements in the row by the same number. That's rule number 1. Rule number 2, we are allowed to interchange rows. For example, I can take row number 3 and place it in the first row, take row number 1, and it occupies row number 3. Rule number 3, we can add or subtract a multiple of one row onto another row. So I can take row number 4, multiply it by 30, and add it onto row number 1. It's perfectly legitimate. So let's get started remembering these rules. So as I said previously, we want to make everything below this one here equal to 0. So how do we do that? Let us multiply, to get rid of this 4 here, let us multiply row number 1 by minus 4 and then add it to row number 2. So let's abbreviate the process by saying we are going to add to row number 2. So it's row 2 minus 4 times row number 1. Let's get this straight. I'm going to take row number 1, multiply it by minus 4, and add it on to row number 2. So what do we get? We get, so 4 minus 4 here, plus this 4, that gives us a 0. So first of all, let me write my 1, 2, 3, and 11. Now, minus 4 plus 4, I get a 0. Minus 8 plus a 7, I get a minus 1. A minus 12, because remember we are multiplying row number 1 by minus 4, adding it onto row number 2. So minus 12 plus 2 gives us a minus 10. Minus 11 times 4, which is minus 44, plus 23, I get it minus 21. Row number 3 is unchanged, so it's 2, 1, 5, 17. There's our new matrix. Now, we still have got these 2 to get rid of. So what must we do? Let's multiply row number 1 by minus 2 and add it on to row number 3. So we are going to say row number 3 minus 2 times row number 1. What do we get? So our row number 1 remains the same. So it's 1, 2, 3, and 11. 0, minus 1, minus 10, minus 21. Now, let's deal with row number 3 now, given this process. So, minus 2 plus 2, that gives us a 0. Down here, minus 2 times 2, which is minus 4, plus 1, that gives us a minus 3. A minus 6 plus a 5, that gives us a minus 1. A minus 22 plus a 17, that gives us a minus 5. Am I right? 22, 11 times 2 is 22, plus 17, that's a minus 5. So this is our new matrix. Now, let's remember rule number 1. Rule number 1 says we are allowed to multiply any row by any constant that we like. So let's get rid of the minus signs in row 2 and 3 by multiplying both of them by a minus 1. So that gives us here, take note of the fact that I'm not putting an equal sign. I'm just putting this sign here because this is not equal to that. So let's write our row number 1 is 1, 2, 3, 11. Now we are multiplying everybody here by minus 1, so that gives you 1, 10, and 21. Down here, that gives us a 3, 1, and a 5. Okay, that looks neat, doesn't it? The minus signs are gone. Now, Our next assignment now, remember we have gotten rid of all the elements that were below this one here. We still need to get rid of every element that is below this new one here in row number 2. So we get rid of these 3. How do we do that? Let's multiply row number 2 by minus 3 and add it on to row number 3. So we are going to say row number 3 minus how many times? 3 row number 2. Okay, I hope you can see that. So what does that give us? Our row number 1, of course, remains the same. So we have here 1, 2, 3, and 11. Row number 2 is 0, 1, 10, and 21. But we are going to add minus 3 times row number 2 onto row number 3. So minus 3 plus 3, that gives us a 0. A minus 30 plus a 1, that gives us a minus 29. A minus 63 plus a 5, 63 minus 5, that gives us a minus 58. Am I right about that? Yeah, sure. So there's a new matrix there. Right. Again, we can apply here rule number 1 because I hate negative signs. So we need to get rid of negative signs here. In addition to that, we can divide right through by 29 because 29 goes into 58 twice. So we can do 2 operations at the same time. Number 1, divide by 29, and number 2, multiply by minus 1. So that gives us a 1, 2, a 3, and 11. Then a 0, 1, 10, and a 21. But down here, remember, we are dividing by minus 29 actually. So that gives us a 1 here. A minus 58 divided by minus 29, that gives you a 2. Now, this new matrix is quite interesting because if you look carefully, it's got a 1 here, and to the left of it, down below, it's zeros. To the left of that, there's a 1, then a 0. Then comes here on the third row, there is a 1. These elements here that we are left with are what are called pivot elements or pivots. These are pivots. And the columns that contain the pivots are called pivot columns. Pivot columns. These are pivot columns. So this is a pivot column, this is a pivot column, this is a pivot column, but this is not a pivot. The new matrix that we have created out of all these operations is called it's said to be in row echelon form. So we have transformed our matrix here into row echelon form. The characteristic of a matrix in row echelon form is what I've just said here. It's got these elements here. Everything below the elements are 0. So we've got zeros here, and leading ones or pivot elements everywhere else. Now, what's the next step? The next step now is to get rid of everything above the pivot elements. So here, of course, there's nothing to get rid of. Here, we need to get rid of these 2. Here, we need to get rid of this 10 and this 3, and so forth, for this column and that column. So let's get busy and do that. So our first row becomes 1. We need to multiply this row here, row number 2, by minus 2 and add it on to that in order to get rid of this 2 here. So we are going to have 0 here because it's minus 2 plus 2 is 0. But we are multiplying everything by minus 2, so this becomes a minus 20 plus 3, which gives us a minus 17. This gives us a minus 42. 2. Am I right? A minus 42 plus 11, that gives us a minus 31. Am I right? 42 minus, yes, that's right. Right. Then here we've got a 0. We've got our 1 here. We have got our 10. We've got our 21. We've got our 0, our 1, and a 2. Right. Next assignment. We now want to get rid of all these guys above this pivot here. So we can hit 2 birds with 1 stone here, can't we? So let's do it all at once. So we're going to have a 1 here, a 0 there. We multiply row number 3 by 17 to get rid of this one here. So it's minus, yes, sorry, not a minus 7, but a plus 17, because already that one is a minus 17. So we say 1 times 17 plus 17, that gives us a 0. 2 times 17 gives us a 34. 34 minus 31 gives us a 3, isn't it? 34, yes, it gives us a plus 3. In row number 2, we've got a 0 here, a 1 here, but we need to get rid of this 10. So multiply row 3 by 10, minus 10 this time, and add it on to row number 2. So minus 10 plus 10, that gives us a 0. 2 times minus 10 is a 20. 20 minus 20 plus 21, that gives us a 1. Then here we have got a 0, a 1, and a 2. Now, here's a new matrix. Let's remember one thing. Our augmented matrix was this coefficient matrix plus these constants over here. And we had a red line drawn between them. So let's reproduce this red line here. So this is our matrix A now. And this is what has resulted of our constants. But what does this matrix mean? If we go back to our equation, this represents our x, this represents our y, this represents our z. So basically what it's saying here is x plus 0 is equal to 3, which means x is equal to 3. So our x is equal to 3. In row number 2, it's saying 0 plus y plus 0 is equal to 1, which means y is equal to 1. So y is equal to 1. In row number 3, it's saying 0 plus z is equal to 2, meaning our z is equal to 2. Incidentally, this matrix here that we have created as a result of all these elementary row operations or this algorithm is actually called a matrix in reduced row echelon form. So let's write it over here. So this matrix now is in reduced row echelon form. Remember, when it was in this form here, we said it was in row echelon form. When we further reduce it to this level here, it becomes reduced row echelon form. As you can see, our equation, the solution to our equations is unique. Otherwise, we would normally get what is called a general solution. A general solution is one that involves some parameter, so that the solution is an infinite number of solutions and it depends on the value assigned to the parameter. In my next video, I am going to select a matrix or a set of equations that results in a general solution. So watch out for it. If you are not a subscriber, please do subscribe and press the like button and keep a lookout for the new video. Till we see you, bye-bye.